Hello there, and welcome to day 66 of the 100 Days Python Programming Challenge. On day 44, we talked about prime numbers, but there's also something called the reverse of the prime numbers, Emery or something, I don't know what to call it. But then it's when you have a prime number and then you reverse it, and the reverse is also a prime number. So for instance, 13 is a prime number. If I reverse 13, that is 31. So is 31 also a prime number? Yes, that means that 13 is a unique number called an Emery number. An Emery is just prime reverse. So today I will show you how you can do that in Python. Check if a number is a prime number and if its reverse is also a prime number. It's day 6 and 6, 66. Let's begin.
Hello there and welcome back. It is day 66 of the 100 Days Programming Challenge. Let me zoom the screen a little. And today we will be checking if a number is an Embry number in Python. This is just prime reverse. So that gives you an idea of what we want to do. So it is a prime number that when the digits are reversed, it forms another prime number. So for instance, we have 13, and then when we reverse 13, it becomes 31. So 13 and 31 are prime numbers. So they are considered Emery's. I don't know how to call this. So the steps that we'll take is to first check if a number is a prime number, and then we'll reverse the digit of the number, and then we'll check that the reverse number is also a prime number, and then we'll ensure that the number is not a palindrome. That is, for instance, if you have a number that is 33, you reverse it, it's still going to give you 33. So there's no point checking that it's if it's a prime number and if it's an M something. Reverse prime. Let's just stick with reverse prime. So remember on day 44, we talked about we created a program that checks if a number is a prime number or not. So this is the function that checks the prime number. If you have not checked day 44, I suggest you do so because I won't be explaining this. And then we'll use this exact same function as it is still valid in our day 66. So we'll check if a number is a prime number using this function, and then we'll reverse the digits of the number, and then we'll check if the reverse number is also a prime number. And if it's a prime number, we'll print a message that we've found a number that is a prime number and its reverse is also a prime number. So this is our function that determines if a number is a prime number or not. And then we have to have our function that we would use to reverse the prime number. So let's have dev. And what I would do is to convert my number into a string, and then I will perform the reverse on it and also convert it to an integer. So I'll convert n, which will be my prime number, into a string, to slice it to reverse it, and then convert it back into an integer. Let me show you what I mean. So n, I have to put the my parameter, which is num, because we're using num, and then I would return. So int string, we're doing a lot of conversions here, and then I have num, and then this is how I would do my slicing. And this is what we'll do. I'm converting it to a string, performing my slicing. I want it to start from the end and then converting my information back to an integer. So then I'll be able to check it in my function. So now the function to now do check if the number is empty or not, I would have my this is my second function. Not is prime. So for every number, I'm calling this first to check if it's a prime number. If it is not, then it should return the false. But then if it is a prime number, then it should perform the reverse. And how do we perform the reverse? We perform this reverse in this function. So this is time I have to call this function. So I'll have reverse n is equal to my reserve number. I can just copy this and paste it here. So here I'm calling my function. And then I will check if the reverse number is a prime and if it is not equal to the original number. So I'll have an if condition that if of n. So this means my reserve number, is it equal to num? If it's equal to num, then it's the same thing. If it's not equal, then I can then perform my whether it is prime. So I'll have is prime. And what am I checking if it is prime? I'm checking this, my reverse n. And then I would return true if this is a prime number. Do not forget the colon for the if statement. So return true. And then if it is not, then I return false. So this is our function. This is what we're trying to do. So we're checking if it's we have a function for the prime number to check if it's a prime number. We have a function that reverses the number that we enter. We're getting the number from the user, and once we get the number, we reverse it. And then we have this: is it a prime number, a reverse prime number? So we first check is it a if it's not a prime number, then we return false. Otherwise, we'll reverse it. First number num, and then if the reverse number is the same with our number, then we know that it's the same number. That's how we have that if it's not equal. And if it is a prime number, then we want to return true that it is a prime number. So now let's have our input statement to get the input from the user. So this is how we get the input from the user. And as usual, we're converting it to int. So once we get the number, then we want to have like an if condition. That is it a prime number? Is it an reverse? If the reverse number also a prime number, then we want to print that it is true. Or if it is not, then we want to print that it is not. So I would have an if else statement that actually checks this. So this is what we have. We get our input from the user, we get the number, and then we then call this function to our number. And what the function does is that it checks if it's a prime number by calling this function. If it's not a prime number, then it just returns false. If it is a prime number, then we reverse it. So by reversing it, we're calling this function. This is the reverse number function that we called here. And then we now have to compare that is the number that we reversed, is it the same with our original number? And when we call this prime number, is this prime function on the number, is it also, did we also get true? If we got true for both, then we return true. If we did not get true, then we return false. So now let's run the function. So if I have 13, we get that 13 is because when you reverse 13, you get that 13 is 31, and 31 is also a prime number. If you want, let's print out. Let me add a print statement here so you can see the reverse number. And if I run it, you see 13. We see 31 because 13 was reversed to 31, and then we then check that is prime on the reverse number, and we see that it is on the reverse number.
That is it for this video. Do not forget to subscribe, to like, and leave a comment. Let me know if you have any questions. And as always, the link to the Jupyter notebook is in the description. See you tomorrow.